Ladies and gentlemen, welcome to another episode with Excellence Tuition Center. Today we are going to be revising Section B, Zimsec O-Level Mathematics Paper 2, November 2014 session. Section B, it carries 36 marks. The instruction is answer any 3 questions in this section, but for the sake of our revision, we're going to revise all the questions. Each question carries 12 marks. So number 7, it reads, a farmer has a square orchard of side 10 meters. He decides to extend it by increasing the length of one side by x meters and the other by 2x meters as shown in the diagram below. So this side has been extended, so the extension starts from here to here, which is 2x. So the whole of this side becomes 10 plus 2x, and this side you have extended from here to here by x meters. So the whole of this side is 10 plus x. So the first question now reads, write down an expression for the total area of the extended orchard and show that it simplifies to 2x squared plus 30x plus 100. So we just want to find the area of this square. So the area is just side times side. So this side it's 10 plus 2x multiplied by this side, which is 10 plus x. And you are going to say 10 multiplied by 10, that is 100. 10 multiplied by x, we get plus 10x. 2x by 10, that is plus 20x. 2x by x, that is plus 2x squared. And if we simplify here the like terms is 10x and 20x. So we're going to have 100 plus 10x plus 10x, that is 30x plus 2x squared. And if you start with 2x squared, it's going to be 2x squared plus 30x plus 100. So we've shown that it simplifies to 2x squared plus 30x plus 100. Now, part B, it says write down and simplify an expression for the area of the extension. So the area for the extension, we now want the area for this part only. This is the part that you want. So you can divide it into 2 sections. You can divide it on this side, so it becomes this rectangle here and another rectangle here. So this one, it measures 10 meters by x meters, which is equal to this side, and this one is 2x by this side, which is 10 plus x. So we're going to say the total area, add the areas of the 2 rectangles, this rectangle and this rectangle. So this rectangle, it is 10 multiplied by x plus this rectangle is 2x multiplied by 10 plus x this side plus 2x multiplied by 10 plus x equals 2. So 10 times x, that is 10x, 2x times 10, that is plus 20x, 2x multiplied by x, that is plus 2x squared. So this is equals to 10x plus 20x, you get 30x plus 2x squared. You can rewrite it as 2x squared plus 30x. Part C, it says, given that the area is increased by 8,87,5 square meters, form an equation in x and show that it reduces to 2x squared plus 30x minus 87,5 is equals to 0. So here we are told that this is equals to 87,5 because that is the area of the extension that we have increased our orchard. So here we are just going to say 2x squared plus 30x minus 87,5. Sorry, 2x squared plus 30x is equal to 87,5 because this is equal to 87,5 square meters. And if this comes to the left side, it becomes 2x squared plus 30x minus 87,5 is equals to 0. We've shown that it reduces to 2x squared plus 30x minus 87,5 is equals to 0. Part D, it says solve the equation 2x squared plus 30x minus 87,5 is equal to 0, and it carries 4 marks. So now we're required to solve the equation that we formed in part C So in part D, we have 2x squared plus 30x minus 87.5 is equal to 0. So in order to solve this, we are going to use the quadratic formula, which states that x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So here our a is equals to 2, our b is equals to 30, our c is equals to minus 87.5. So if you substitute our a and b and c, we are going to get minus 30 plus or minus 30 squared minus 4 multiplied by 2 multiplied by c minus 87.5 over 4. And if you simplify under the square root sign, we are going to have minus 30 plus or minus square root of 1600 over 4. And if you solve, the first one is minus 30 plus square root of 1600 divided by 4, we get 2.5, or if you say minus 30 minus square root of 1600 over 4, get minus 17.5. So here we are going to say therefore x is equal to, therefore x is equal to 2.5 meters, just because here our x represents a length, so the length cannot be negative, so the correct answer is 2.5. And then the last part of the question, it says write down the actual length of the extended orchard. So the actual length of the extended orchard, we are going to simplify here. So here it's going to be, so this is the length, the longer side is the length, so it is going to be, as an expression in x, it is 10 plus 2x. So we are going to substitute our value of x that we have obtained in part D. So it's 10 plus 2 multiplied by 2.5, and then it becomes 10 plus 5, so this is 15 meters. Question 8, it is a transformation question. It reads, answer the of this question on a sheet of graph paper. A triangle PQR has vertices P at P 1, Q 3, 4, and R 4, 0. Using a scale of 2 centimeters to represent 2 units on both axes, draw the x and y axis for minus 10 is less or equal to x is less than 10, and minus 6 is less or equal to y is less than 6. So what it just means that the values of x are starting from minus 10 up to 10, and the values of y are starting from minus 6 up to 6. And the first question reads, draw and label triangle PQR. So here I've already drawn the x and the y axis using the scale of 2 centimeters to represent 2 units. So this is our triangle PQR. Point P, this is 1 on the x-axis and 1 on the y-axis, and our point Q, this is the point 3 and 4, and our point R, that is 4, 0. The next question, it reads, triangle PQR is mapped onto triangle P1Q1 R1 by a transformation N, where N is represented by the matrix minus 1, 0, 0, minus 1. Draw and label triangle P1Q1 R1. So for us to be able to draw this triangle, we first of all need to calculate the image points. So we use the formula which says that the image is equal to the operator matrix multiplied by the object. This is the formula that we use. So our operator matrix is represented by the matrix N, which is the transformation matrix, which is minus 1, 0, 0, minus 1. And now our object, it represents the vertices of our original triangle with point P, which is 1, 1. So we're going to put 1, 1 here. And our point Q, that is 3, 4. So we're going to put 3, 4 here. Our point R, that is 4, 0 here. So this is point P, this is point Q, this is point R. And we are going to multiply this matrix multiplied by this matrix. So here, this is going to be minus 1 multiplied by 1 plus 0 multiplied by 1. So we are going to get minus 1 here. Minus 1 by 3, that is minus 3, plus 0 by 4, that is 0. Minus 1 by 4, that is minus 4, plus 0. And then here, we are going to say 0 by 1, that is 0, plus minus 1. So this is going to be minus 1. 0 times 3, that is 0, plus minus 1 times 4, that is going to be minus 4. 0 multiplied by 4, that is 0. Then minus 1 by 0, that is 0. So these are the coordinates for the vertices of our image triangle. This is point P1, this is point Q1, and then this is point R1. So after having calculated our coordinates for the object, for the image here, this is P1. So the image points, this is minus 1 for the x and minus 1 for the y. And then point Q1, it is minus 3, minus 4. So this is the point minus 3 on the x-axis and minus 4 on the y. And our R1, that is minus 4, 0. Now the next question, it reads, describe fully the single transformation represented by matrix N. So this matrix represents a clockwise rotation by 180 degrees about the origin. So that is the single transformation represented by matrix N. Now question C, it reads, triangle PQR is mapped onto triangle P2Q2 R2 by a translation T, which is represented by the vector 5 minus 2 and then followed by the transformation N. So I want to calculate the coordinates of the vertices of triangle P2, Q2 and R2. So here we are told that the first is the translation of 5 minus 2 and then it is followed by the transformation N. So what we are going to do is first of all calculate the image after the translation for this vector. So point P is 1, 1, and if it is translated by the translation vector 5 minus 2, we say 1 plus 5, this is 6, 1 plus minus 2, that is minus 1. So this is the image. And then point Q, it is the point 3, 4, and if you translate it by 5 minus 2, say 3 plus 5, that is 8, 4 plus minus 2, that is 2. And for point R, it is the point 4, 0, and we are going to translate it by 5 minus 2, so 4 plus 5, that is 9, 0 plus minus 2, that is minus 2. So it means that our image points is 6 minus 1, 8, 2, and 9 minus 2. So here we are now going to use our formula again, which says image is equals to operator matrix multiplied by the object. So now the vertices for the object, we are going to use these ones. So our operator matrix is still the matrix N. So here we are going to use our matrix N, which is minus 1, 0, 0, minus 1, multiplied by our object. I'm just going to put all the points. So it's 0.6 minus 1, for the image of P under that translation, and we have 82 image of Q under our translation, and point R, this is 9 minus 2. And if you simplify this, say minus 1 times 6 plus 0 times minus 1, we're going to have minus 6, minus 1 by 8 plus 0 times 2, we're going to get minus 8, minus 1 by 9 plus 0 times 2, we're going to get minus 9, 0 by 6, you're going to get 0, plus minus 1 times minus 1, you're going to get 1, 0 by 8, that is 0, plus minus 1 by 2, that is minus 2, 0 by 9, that is 0, plus minus 1 times minus 2, that is 2. So this is now P2, Q2, and R2. So these are the coordinates. It's minus 6, 1 for P2, and minus 8, 2 for Q2, minus 9, 2 for R2. Then the last part says draw and label triangle P2, Q2, R2. So this is our triangle P2, Q2, R2. Our P2 is minus 6 and 1, and Q2, that is minus 8 and minus 2, and then our R2, that is minus 9 and 2. So that's for question 8. Number 9, it reads, answer the whole of this question on a sheet of plain paper. The table shows the number of books borrowed from a university library in 1 week. So here it's subject and number of books. For geography, we have 30 books, science we have 45, maths we have 25, Shona, that's 20, theory of education, that is 60. Part A, it reads, find the total number of books borrowed in that week. So we are simply going to add 30 plus 45 plus 25 plus 20 plus 60. So here the total, that is equal to 180 books. This is the total number of books borrowed in that week. And then part B, it reads, express the number of theory of education books as a fraction of all the books borrowed in its lowest terms. So the total number of books borrowed in that week was 180 books, and the theory of education books borrowed were 60. So we are going to say 60 over 180, and we are going to reduce. So we cancel this 0 and this 0. 6 into 6, that is 1. 6 into 18, that is 3. So it becomes 1 over 3. Part C, it reads, show this information on a clearly labeled pie chart. So what you need to do there is to calculate the angles which are going to be represented by each subject on a pie chart. So for geography, for geo, we're going to say 30 over 180 multiplied by 360. That's because on a complete revolution, you have 360 degrees. So we want to find the fraction of each subject on the 360 degrees. So for geography, 30 over 180 multiplied by 360, get 60 degrees. For science, that is, for science there were 45 books borrowed, so it's 45 over 180 multiplied by 360, and that is 90. For maths, 25 books were borrowed, so it's 25 over 180 multiplied by 360, which is equals to 50. For Shona, that is 20 over 180 multiplied by 360. So the angle here, that is 40 degrees. And for theory of education, that is 60 over 180 multiplied by 360, and then we get 120 degrees. So now we are going to draw a circle and divide into these angles using a protractor. Okay, so draw the circle, and then we're going to mark using a protractor each angle. So here This line just acting as a baseline. We're going to measure using a protractor. So make sure that this line is directly on top of the baseline, and also the center of the circle is directly here. So 60 degrees measuring from this side. So it's going to mark here. That is your 60 degrees. And then just join the line which connects from the center of the circle to the circle here. So this is our 60 degrees. I just want to say 60 degrees here. So this one, it represents geography. And for science, we have 90 degrees. So again, measure 90 degrees. Make sure that the center is directly over here. And then this line is on the same, is in the same plane with this one. And also here, this is 90 degrees. So our 90 we mark here. Then we join the line from the center to that line. So this is 90 degrees. So here we have 90 degrees. So this is representing science. So the whole diagram, it looks like this. So we have 60 for geography, and this is 90 for science. For maths 50, shoulder is 40, and for theory of education that is 120. So that is our pie chart. 9D, the question reads, 2 students borrowed books from the library during that week. Calculate the probability that the first student borrowed a science book and the second borrowed a maths book. So we are going to use the formula which says probability is equal to possible outcomes over total. That's the formula that I'm going to use. So the probability for borrowing a science book, we have 45 students, so it is going to be 45 over 180. Now we are using the word and, so if it's and or both, we multiply. So here, since we have removed one student from the total of 180, the probability of having a maths book being borrowed here, we are going to say it is 25 over 179. So the total reduces by 1 because we've already picked one student which has borrowed a science book. So if we simplify here, it becomes 25 over 716. Question 10. Answer the whole of this question on a sheet of graph paper. The velocity v meters per second of a moving body at time t seconds is given by the formula v is equals to t squared minus 3t plus 5. Below is an incomplete table of values for v. So this one is going to be a quadratic graph, so it is going to be curved. So it is a quadratic because here we have a term which is to the power of 2, and it is in the general form ax squared plus bx plus c is equal to 0. So this one is going to be a curved graph which is similar to a quadratic graph. So the first question says find the value of m and the value of n. So here we are going to use our formula for the graph. V is equals to t squared minus 3t plus 5. So the value of m is the value of v when t is equal to 0. So m is equals to, so substitute on t we put 0 minus 3 times 0 plus 5. So our m is going to be equal to 5, and our n, it is equal to, so our n is the value of v when t is equals to 4. So we say 4 squared minus 3 multiplied by 4 plus 5. 4 squared, that is 16, minus 3 times 4, that is minus 12, plus 5. 16 minus 12, that is 4 plus 5, that is 9. So our n, our m is equal to 5 and our n is equal to 9. Part B, it reads, using a scale of 2 centimeters to represent 1 second on the horizontal axis and 2 centimeters to represent 5 meters per second on the vertical axis. Draw the t and v axis for 0 is less or equal to t is less or equal to 7. So here what it means is that our time we're going to put it on the x-axis, the horizontal axis, and our velocity we're going to put it on the vertical axis, which is the y-axis. So the time it is going to take the values from 0 to 7, and our velocity, the smallest value, that is 3, and the largest, that is 33. So we're just going to fit it using the scale that we are told here. Part B, it reads, using a scale of 2 centimeters to represent 1 second on the horizontal axis and 2 centimeters to represent 5 meters per second on the vertical axis. Draw the t and v axis for 0 is less or equal to t is less or equal to 7. So here what it means that our time values are going to be from 0 up to 7, and we are going to represent t on the x-axis, the horizontal axis, and our velocity with a scale of 2 centimeters to 5 units on the y-axis, the vertical axis. So it says draw the graph of v is equals to t squared minus 3t plus 5. So I've already drawn the graph. So this is our velocity, meters per second. It is a scale of 5, 10, 15, 20, 25, 30, 35. And here our time on the x-axis from 0 up to 7. So our curve is like this, follows a quadratic curve. Now on part C, it says use your graph to estimate the values of t when v is equals to 4. So here we just come on our graph, and here it's 1. So these small boxes, 2 small boxes, they represent 1 unit. So here is 1, 2, 3, and 4. So our v is equal to 4 is here. So just draw a dotted line here. So where it cuts our curve, those are the values of t when v is equal to 4. So the first value here in this, each box is representing 0,1. So it is 0,1, 2, 3, 4. So it's 0,4 seconds, and here this is 2,1, 2,2, 2,3, 2,4, 2,5, 2,6 is 2,6. So it means on C item 1, t is equals to 0,4 or 2,6 seconds. And then our item 2, see item 2, it reads use a graph to estimate the acceleration when t is equals to 3. So here what you just need is to draw a tangent to a curve where t is equals to 3. So I draw a tangent, this is our tangent, and just pick 2 points on either side here. So this point and this point. So this point, the coordinates, that is 2, and this is 1 and 2. So this is 2, 2, and this is 4, and here this is 5, here 6, 7, and 8. So this is 4, 8. So this point, we can say this is x1, y1, this is x2, y2. So the acceleration is equal to the gradient for a velocity time graph. So our acceleration is equals to y2 minus y1 over x2 minus x1. So our y2, that is 8, minus y1, that is 2, over x2, this is 4, minus x1, this is 2. So 8 minus 2, this is 6, over 4 minus 2, that is 2. So 6 over 2, that is 3 meters per second squared. And the last question is the distance traveled from t is equals to 4 to t is equals to 6. So here the distance for a velocity time graph is just equal to the area under the graph. So from t is equals to 4 up to t is equals to 6. So t is equals to 4, is this line, and t is equals to 6 is this line. So here what you just need to do is to count the number of squares under the graph. So these 4 boxes, they just represent 100 squares. Here is 100 squares. Here also you have 100. You have also 100. And then you can also count this. So let us say we have 100, 200, 300, 400, and 500. Let me just estimate here. Let us say here we get 150. So it's 500 plus 150. So we're going to get 650. So we just say the answer, it will be 650 meters. But in the exam, under some situation, you really need to count all the squares and get an accurate value. On question 11, it reads, a regular polygon has an interior angle that is twice the exterior angle. Find item 1, the number of sides of the polygon. So here, just draw a snapshot of one interior angle and one exterior angle. So it says the interior angle is twice the exterior angle. So assuming that the exterior angle is x, the interior angle, which is twice, becomes what? 2x. So we know that the interior angle plus the exterior angle, they add up to 180. So you say 2x plus x is equals to 180. We're going to get 3x is equals to 180. Divide both sides by 3, divided by 3. We're going to get x is equals to 60 degrees. So this means that our exterior angle is equals to 60 degrees. And if you are using the exterior angles, you know that the exterior angles, they add up to 360. So for us to get the number of sides, we're going to say the total sum for the exterior angles divided by 1 of the angle. So 360 divided by 6, we get 6. 360 divided by 60, we get 6 sides. Item 2, it reads, the sum of the interior, find the sum of the interior angles of the polygon. So we are going to use the formula, sum is equals to n minus 2 multiplied by 180. We have 6 sides, so it becomes 6 minus 2 multiplied by 180. 6 minus 2, this is 4 multiplied by 180. We get 720. Part B, the question reads, we have a diagram. It says in the diagram, the points A, B, C, and D, so it's A, B, C, and D, lie on level ground. A, B, C is a straight road, so this is a straight road which runs in a west-east direction, so it's from west to east. AD is equals to BD is equals to 9 kilometers. So AD is equals to BD, they are both equal to 9 kilometers. ABD is equals to 40 degrees, and BC is equals to 6 kilometers. Calculate the bearing of A from D. So the bearing of A from D, here, and just redraw this triangle. So I've redrawn the diagram. So here, this is side, this is A, D, B, and C. So A, B, C, D. So we want to find the bearing of A from D. So we take a clockwise rotation from the point, from the north of the point where we are starting from. So it's from D. So this rotation, the clockwise rotation in this direction, that's the one that we want. So the angle that is we want is from the north of point D up to the line which joins point A and D. So here, this is also the north of A, right? So since this side is equal to this side, it means this triangle is an isosceles triangle. So here we also have 40 degrees, and here the north and the west-east direction, the whole of this angle is 90 degrees. So this angle here, this is 90 minus 40, so this angle is 50. And then if we use this north is parallel to this north, So this angle plus this angle, using the concept of co-interior angles, this angle plus this angle, they add up to 180. So to get this angle, I'm going to say 180 minus 50. So this angle here is 130. And here this is an angle on a point. So for complete revolution we have 360 degrees. So if this part is 130, the one that we want for the bearing, we will say 360 minus 130, and we get 230. So this means that our bearing of A from D is 230 degrees. Item 2, it reads, calculate the distance CD. So the distance CD, we want to calculate this distance. So for us to calculate that distance, we can use the cosine rule. So we can use this side and this side, and also find this angle. So since here it is a straight line, we just say 180 minus 40. So this angle here is 140. So item 2, we want to find the distance CD. So it's from C to D. So here our angle is 140. This side is 6, and then this side is 9 kilometers. So you can just say CD squared is equals to 9 squared plus 6 squared minus 2 multiplied by 9 times 6 cos 140. So this is the cosine rule. So if you simplify this side, it becomes 117 minus 108 cos 140. So CD is equal to CD squared, and then we square both sides, put square root both sides. So this one cancels this one, and CD is equals to square root of 117 minus 108 cos 140. So the answer is 16 kilometers. And the last part, it says item 3, calculate the area of triangle BCD. So we want to calculate the area of this triangle BCD. So if the triangle does not have a perpendicular height, we can use the formula which says area is equals to half AB sine theta. So when you have a triangle which is like this, you have an angle here, included angle between two sides. For us to find the area, just say half multiplied by this side, multiplied by this side, multiplied by the sine of the angle. So here you can take this as our A, and then this is our B, and then our angle is 140. So it means our area is equals to half multiplied by 9 multiplied by 6 sine 140, and then this is equals to 17,4 square kilometers. So we're using square kilometers because our measurements here were in kilometers. Question 12, it reads, in the diagram, ABC is a triangle in which AB is equals to Q and AC is equals to P. M is the midpoint of AB and X is a point on BC such that BX to XC is equal to 4:1. CM and AX intersect at Y. Part A, expressed in terms of P and OQ BC. So I've already redrawn the triangle. So I want to find side vector BC. So BC is moving from B to C. So here you can say that BC is equal to BA plus AC. So our BA, since we are moving in the opposite direction of vector Q, is going to be minus Q plus P. Item 2, find CX. So CX, it is moving from C to X. So CX, here we are told that BX to XC is 4:1. So from B to X is 4, from X to C that is 1. So the total is 5. So what it means that our CX it will be 1/5 of what? Of CB. And since we are moving in the opposite direction of BC, we're going to put a negative. So CX is equals to minus 1/5 of BC. So our BC is minus Q plus P, the one that we calculated in item 1. So this is minus 1/5 multiplied by minus Q plus P. Minus 1/5 by this becomes 1/5Q. Minus 1/5 by P becomes minus 1/5P. Now we want to find CM. So CM is moving from C to M, from C to M. So we're saying this is CA plus AM. So our CM, item 3, our CM is equals to CA plus AM. So CA is in the opposite, we are moving opposite direction of P. So CA, this is minus P plus AM is in this direction, and we're told that M is the midpoint, so AM is half of AB, which is half Q. So this is our CM. And item 4, we want to find AX. We want to find AX. So AX is equals to, so it's from A to X. So we're going to use AC plus CX. So this is AC plus CX. So our AC, we already given it as P, plus our CX, we already calculated it in item 2. So another trick when calculating vectors, you can check if you can use the vectors that you have already calculated in the question or in the vector that you want to calculate. So our CX, this is plus 1/5Q minus 1/5P, the value of CX that we've already calculated. And here we simplify here and collect like terms, so it is going to be P minus 1/5P plus 1/5Q. And if we simplify here, P minus 1/5P is going to be 4/5P plus 1/5Q. So our part B, it reads, given that CY is equals to KCM, express CY in terms of P, Q, and K. So CY is equals to KCM. We've already calculated CM, so we're saying CY is equals to KCM. We're just going to say K multiplied by our CM, that is minus P plus half Q. So if you expand here, K times minus P, this is minus KP. K times half Q, this is plus half KQ. So you get this is minus KP plus half KQ. Item C, it is given also that AY is equals to HAX, express CY in terms of P, Q, and H. So here I was told that AY is equals to HAX, express CY in terms of P, Q, and H. So CY is equal to CA plus AY. So we need to include this AY to express our CY in terms of P, Q, and H, since we are given this relationship. So CY is equal to CA. So CA is minus P plus AY. AY is the one that we're given being equal to HAX. We calculated HAX before, which is 4/5P plus 1/5Q. So this is H multiplied by 4/5P plus 1/5Q. So it's minus P, and if you expand here, it's going to be H multiplied by this is 4/5HP. This multiplied by this is plus 1/5HQ. And if we factor out p here, it's going to be minus 1 plus 4 over 5h multiplied by p plus 1 over 5h cube. Now on part D, it says using the results of B and C, find the values of h and k, hence express ay in terms of p and q. So part D here, we need to solve a simultaneous equation. So we can just start by saying cy is equals to cy. So our first cy is this one that we calculated in part B. So in part B, our cy, we got it as minus kp plus half kq equals to cy. In part C, we found it as minus 1 plus 4 over 5 h by p plus 1 over 5 h cube. So we compare coefficients. So by comparing coefficients, so I'm just going to take the coefficient of p on the left being equal to the coefficient of p on the right. So I get minus k is equals to minus 1 plus 4 over 5h. This is equation 1. And the coefficient of q here is half k equals to the coefficient of q this side, it's 1 over 5h. And this is equation 2. So if you solve these two equations simultaneously, you get k being equal to 1 over 3 and h being equal to 5 over 6. If you solve those two equations simultaneously. Now, I also taught that hence we express ay in terms of p and q. So ay is equal to hax. So ay is equal to ha. So ay is equal to hax. Our h is equals to 5 over 6. Our ax, we found it as 4 over 5 p plus 1 over 5 q. And if you simplify this, you expand here, so 5 by 4, this is 20 over 6 by 5, that is 30p plus 5 by this is 5 over 6 by 5, that is 30q. And if you reduce here, you get 2 over 3p plus 1 over 6q. Well, ladies and gentlemen, that is the end of our revision on Mathematics Paper 2, November 2014 session. Don't forget to like, share and subscribe, and stay tuned for more videos on revision on various subjects